hope I can keep you entertained. So I'm going to talk today about Varnish and how to make it work with Symfony. First of all, let me introduce myself. I'm Carlos Granados. I live here in Spain, in Galicia. And I've been developing Symfony applications since 2010, and a Symfony certified developer, one of the first 50. So I'm quite happy about that. And I've been developing software, I would say, most of my adult life. I've been developing software for almost 25 years, and most of that time I've been in, building games, which I love. So I started working with 8-bit computers, then I moved into arcade computers, then mobile, and then I got too old to continue building games. So I moved into the web application and mobile applications, which is what I'm doing now. This is some samples of the work I've done in the past. So first of all, before we move into Varnish, we have to decide, do we really need a cache accelerator? Because Symfony, taking into account all the features that it provides, is really fast. If you get to think all the things that Symfony provides, from database access, all the routing, all the classes, all the annotations, everything, I know, I made a list, and it was like something like 40 different processes that were involved in every single request. And taking that into account, Symfony is pretty fast. I gave a talk on last year's the Symfony conference in Madrid, where I explained all this. And the main thing about Symfony is that it pre-calculates and caches everything. You know, routing, the caching, all the classes, everything. So that's why Symfony is quite fast. So in fact, maybe we don't need a cache application. So let's look at our case test. We have a website which is called clippingbook.com. This is a website where you can build this kind of, we call them visual books. We call it as visual search engine. What you do is you input a term, for example, Fight Club, and then it goes into the web, looks for pictures, videos, text about that thing, and it builds this beautiful book with all this information. This is a real book. You can turn pages, and we think it's a really nice service, and it's going quite well. So we measured, we were running this service in a single server, and we measured that we were able to handle 100 requests per second, which is quite okay. I mean, it's a simple server, nothing fancy, not $2,000 per month server, which is okay. But this wasn't enough to handle our load. You know, especially when we started doing Facebook promotions, when you suddenly posted something on Facebook, and then suddenly 10,000 users came at the same time to your website. And then they brought it down. So we had to do something about that. We couldn't let the website go down. We could have moved into another backend. We could have tried to improve Symfony or anything like that. But we really chose Symfony not because of its performance, but rather because of a lower cost of development and maintenance. We chose Symfony because, as they said earlier, it's simple. And it's easy to use, and it allows you to do things in a logical and simple way. We also did not want to renounce to any of the Symfony features like ORM, tweak templates, which make your life easy. Okay, maybe you can optimize by taking them out, going straight to the SQL code and writing your own PHP display, but what you're going to get out of that is not almost negligible, and you're losing a lot of the things that made Symfony a really nice platform to work with. So we could have also scaled vertically by using a much larger server with much more memory, much more processing power, horizontally by going clustering and distributing into several servers. But we decided to implement a caching strategy first. So our solution was to implement Varnish. Varnish is a cache, a web application accelerator, also known as a caching HTTP reverse proxy. What it does is it sits in front of your HTTP application and caches its responses. So you get a request, Varnish looks up in your cache. If it's there, then it serves it back without going to your Symfony application. If it's not in the cache, then it goes to the backend, asks for it, and then saves it in the cache, so that next request, when they ask for the same information, we can serve it directly from the cache. And the result is that by using just a single Varnish machine and the same old Symfony machine that we were using, now we're all going to be able to serve 10,000 requests per second, which is a 100 times improvement, which I think is a really nice improvement just by putting some software in front of your Symfony environment. This is something that you will never get by optimizing Symfony, optimizing your code, or anything like that. So it's a huge improvement by doing a very simple thing. So I'm going to talk about Varnish. These are the two things I'm not going to cover in this talk. One of them is how HTTP caching works. I hope that you have a general idea of how this works, because I'm not going to go into detail. If you want more information, you can always read the HTTP specification, which is a really good document, and I always recommend that you read it carefully. And the documentation about HTTP caching in Symfony is also great, as is all the Symfony documentation. I really love the Symfony book, and you'll get a very nice overview of how it works in this chapter here. And also, I'm not going to cover basic Varnish installation and configuration. Fabian covered this in a very nice talk he gave in the Symfony in Spain a couple of years ago. I highly recommend that you look at this talk because it's really informational. It has lots of tricks, and it's a great, great introduction to Varnish. So don't worry, I'm going to let you know a little bit about the configuration and how to handle Varnish. So I hope that everything doesn't sound too like Chinese to you. But some cases, if you have never worked with Varnish before or any HTTP accelerator, some of the things may be a little bit strange. So my hope is that even if you don't fully understand what I'm saying now, if at some point in the future you need to install Varnish, you can go back to my talk and find the information you need there. Okay, so this is what I will cover. First of all, I'm going to talk about why we choose Varnish and not other HTTP cache accelerator. A quick overview of a Varnish configuration, just a couple of slides. We're using Varnish 4, which is the new version of Varnish, which was released this spring. And I'm going to talk about what's new because most of the people out there are using Varnish 3, which is the more established version. And if you look for documentation, blog posts, and everything, you're going to find everything about Varnish 3. So I want to talk to you about what's new and what's different here. And then we're going to move into using Varnish with Symfony and look at all these different issues. Okay, so first of all, why did we choose Varnish? One of the good things about Varnish is that it's really, really fast. It's amazingly fast, and it's highly configurable. You can really, with the Varnish language, do anything you want. You can cache things, not cache things, add headers, delete headers, whatever. However complicated your process, Varnish is going to support it. It's really well documented in the Symfony documentation. There are some specific documents about Varnish, so that's a really nice thing also. For example, there's much less information about Nginx or Squid. We have some really nice bundles that help you interact with Varnish. That's another point, a really good point about it. And I have to say I was sold by Fabian's talk. You know, the information that he gave about Varnish and how to configure it and everything, I really loved it, and I was sold. The cons against Varnish. Varnish documentation is, I said here, not good. I'm going to say it's shit. The main thing is that it's very updated. I cannot understand how they put a new version number 4, and a lot of the documentation you find out there is for number 3, for version number 3. And there are many features which are not documented at all, so it's a shame. Also, the configuration language for Varnish can be a little cryptic. It uses a lot of regex, regular expressions. It reminds me of working with Perl, which many of you may love, but I hate. And so it can be a little bit cryptic at times. One of the things which might be a problem with Varnish is it does not handle SSL. So if your website depends on SSL traffic a lot, then you're going to have to do things like putting a server in front of Varnish to terminate SSL and other tricks. So if this is important for you, maybe you need to look at another tool which supports it out of the box, like Nginx. And the last one is not really a problem anymore because mostly all machines now are 64-bit machines. But if you have a 32-bit machine and you hope to run Varnish on it, forget about it. OK, let's look at an overview of how to configure Varnish. Varnish uses VCL, which is a domain-specific language, which is similar to C or Perl. This configuration is saved to a file, which is usually found in this path here. This file, which has this language, is compiled into C. Then it's linked with the main Varnish worker, which means it's really fast. There's no interpreter, no parameters. Everything is turned into binary code and incorporated into the main thread of the worker. So it's really, really fast. And Varnish, what they do is they use a number of routines, which are called at very specific times during the handling of a request. For example, there's a routine which is called when the request is received, another one when we need to look the object in the cache, another one which if we find the object in the cache, another one if we don't. So there's a number of points where you call one of these routines. And these routines, what they do is they return a value, which tells Varnish what to do next. For example, when I receive a request, I may look at it, and I may decide if I want to look it up in the cache or not. So I return a different value, depending if I want to look it up in the cache or not. Also, there's a default VCL code, which is executed if no value is returned. It's really important that if you start working with Varnish, there's a file which has this default code, and you learn what it does. Because you can learn the default case that Varnish is going to do with your request if you do nothing. So that you can then act just on those specific cases that you want to handle yourself, and let Varnish handle everything in the, let's say, normal way. Okay? And then we have some objects which represent the request, the response, the backend request, the backend response, and the object itself in the cache. So this, for example, is a little bit of VCL code. It's a subroutine, which is called when there's a miss on the cache. So we didn't find the object we were looking for in the cache. In that case, what we do is say, OK, we didn't find it, so go and fetch it, which is going to call the backend and fetch the object and save in the cache if appropriate. But for example, here we may decide, in some special cases, even if we didn't find it, I want to return it a special object or whatever. So this is where you start putting your own code. Next slide is really fun, because this is the usual request flow of Varnish. The first time you look at this, you're probably saying, fuck. Because, I know, this looks like crazy, all these arrows going from here to there. With time, it makes sense. With time. But as you say, the flow can be complicated. But it's because there are many special cases. The usual flow is much simpler than that. And I'm trying to give you an overview of it. So for example, we are Varnish and we receive a request. And the first thing we want to do is we decide if we want to look it up in the cache or not. If we do not look it up in the cache, we pass it directly to the backend. And if we do that, we do not store it, because we have decided this is something we do not want to find it in the cache, so we do not store it when it's returned back. This is important to notice. If we want to look it up in the cache, we create a hash so that we can find it in the cache somewhere. Then we look for it, and then we find it or we don't find it. If we didn't find it, then we directly deliver it back to the client. But if we don't find it, we have to fetch the content from the backend. So when we decide that we need to fetch content from the backend, we build a new request for the backend and send it to the backend. And then when we get this response back, we call another routine. And then finally, all these routes come to an endpoint, which is where we deliver this response back to the client. So as you say, so the flow can look complicated, but the main flow, it's more or less quite easy. So what's new in Varnish for? There are a couple of things which I think are the most important ones. One of them is that we are now using different threads for serving the client requests and the backend request. This separation means that we can return content to the client much faster because we can delegate the work of finding the backend content to a separate thread. And we can be serving a stale, which is not yet updated content to the clients while we fetch this backend content. This makes it much more powerful for serving content when you get tons of hits at the same time. This is really important. And another really nice thing about Varnish 4 is that now it correctly handles cache validation, which Varnish 3 didn't. And so it's sending all the headers that need to be sent, and it's processing all the headers that are read back. So you can handle cache validation in your Symfony application now with Varnish 4. For those of you who have used Varnish 3 in the past, I'm going to list some things which have changed. Mainly it's a question of naming things. So for example, what used to be direct request is now the method, for example, post. What used to be fetch is now really split in two. One of them is the VCL backend fetch, where we fetch the backend, and then there's a VCL backend response where we get the response back. To mark responses as uncacheable, you used to set the time to live to 0. Now you have a special flag to mark that. There's no special purge function any longer. To purge content, you return purge from VCL received. And there are a number of names of the actions that have changed. One important thing is that the Varnish log, which is one of the main tools that you're going to use to find out if Varnish is working or not, is a really useful debugging tool, has changed completely. So any sample that you're going to find online on how to use it is not working anymore. They have a new filtering languages, which is much more powerful, but means all the syntax has changed. So you have to use different options, different language, so probably you need to take care of that. So let's move into Symfony. First thing is that Varnish is not only a cache accelerator, it can also act as a load balancer. What it means is that it can have several backends, and then it can decide to call one backend on another depending on several circumstances. So for example, here I have defined two backends, one in one server, another in another server, and I'm using what they call a director, which is something which decides which backend to use. In this case, I'm using a director called hash, which decides which server to use depending on a hash. In this case, we're hashing on client identity, which mainly is the client IP. So what this is doing is that depending on your IP, I'm sending you to one server or the other. Okay, so Varnish includes other balancing mechanisms. For example, you have random, you have round robin, you have URL based, you can build your own depending on many things, on cookies, on whatever, what you like. And Varnish includes a health check mechanism so that it can automatically detect those backends which are down and not send any requests to them. So you have 4 backends and one of them is bad, it's only going to send requests to 3 of them and the other until the other recovers or whatever. The problem with Symfony is that Symfony usually saves sessions in files. So if you use any of the random, round-robin mechanism, this isn't going to work, because the problem is that you're going to get one server which is going to get one request and open a session there, and the next request is going to go to another different server. So for example, if you logged in the first server, then you're not going to be logged in the second server, which is a real problem. So for Symfony, the only safe method to use is hash, and send the people to one server or another, depending on things like the client IP. This is easy to differentiate. The PHP says ID cookie value. This is also can be used to separate one client from another, things like that, things that make a single client always go to the same server. Even this can lead to problems, because if this server where you're sending this client goes down for whatever reason, then you have to send them to a different server, and then the session is lost, which can create lots of problems and things like that. So the best thing to do is to switch to a shared session server where all the session information is saved to a separate server, which is shared by all your backends. You can use that using a database, Memcache, Redis, whatever. There are bundles or session handles for everything like that. So next item, URL normalization. When we store things in the Varnish cache, we use this hash to find out which object we want to retrieve or not. We usually hash on the host and the URL, so that every URL, a combination of host and URL, goes to a different object. The problem is that we need to normalize this in some way, because, for example, you can have URLs with a www or URLs without the www. And you don't want to have two different objects in your cache. For that, you want to have one single object, because the content that is going to be returned to the user is the same. So it's useless to have two different items on your cache for two things. One of them is that they take more memory, so you need a more powerful server to serve that. And the other is that there are less cache hits, because one user may come in for one version and another for a different version, and the second one is not. It could have been a cache hit, but then we have to go back to the backend, even if we already had the comment. So we can do a number of things to help with this. One of them is we can convert all the host, and depending on whether your URLs are case sensitive or not, you can convert all of them to lowercase. You can remove the www if it's present. You can normalize all the query parameters. If you use query parameters, this is important because they may come in any order. And you want to serve the same content, even if the first parameter is one or is the other. So you want to standardize that as well. There's a really nice bundle which redirects all the URLs to a version not ending in /. So in that way, you also avoid a kind of duplication. You know that in Symfony, it's hard to be consistent about that. And you're probably going to have roots which have a / at the end, and other roots which don't have it. By using this bundle, you can redirect all the URLs to the same version so that you are not caching two different versions of every URL. And so for example, this is the routine which creates a hash. So I take the host, I convert it to lowercase, I take the www out of it, and then I sort all the query parameters so that they are always in the same order. One important thing to know about Varnish is that when calculating the hash, it doesn't take into account the vary content. I don't know if you know about vary. Vary is a very important concept that you need to manage if you're going to have a website which is cached. Vary is usually used when there's content which varies depending on one header which is sent. The main example can be, for example, if you have content which varies on the accept language header. You have a website which, depending if your web server says, not the server, the browser says, you know, I speak English, then you send back English content. But if the browser says, I speak Spanish, then you send back Spanish content. So you have to keep two different versions for every URL. This is what we call vary. And Varnish handles that in a special way. It doesn't include it in the hash, and it keeps a different version for each vary combination that you can have. Why does Varnish do that? Why doesn't Varnish include that into the hash calculation? Because then it's much easier to clear content out of the cache by purging it. Because you can, in one swipe, take all the content with all the variations. If we didn't do that, then we will have to first clear the content for English, then clear the content for Spanish, then clear the content for those who handle the zip content, then clear the content for those who didn't handle zip content. So this is the way that Varnish has that keeping all the variations in a single object, logical object, and treat them in a single way. So let's go to the next item, which is cookies and sessions. This is probably the first problem that you're going to find if you want to use Varnish and Symfony. Varnish, by default, will not cache anything which has a cookie. This initially makes sense because a cookie usually means personalization. It's something that we have somehow personalized for a user. But we have the problem that Symfony sets a cookie, the PHP says ID, in almost all responses. As soon as you hit a firewall, as soon as there's a form, as soon as there's anything which needs to keep track of the session, which is almost all the time in Symfony, you're getting back a cookie. So if you set up Varnish as it comes out of the box and you put a Symfony web behind it, you're going to find that nothing is cached. So that was my first surprise I had when running Varnish. I said, Okay, why? It was like I was doing nothing. So the thing is that this cookie, this session cookie, most of the times doesn't produce different content. I say most of the times, but not all the times. So we want to keep this cookie because it's useful. It's keeping sessions. It's keeping things like if you're logged in or not. But many times we do not want to serve different content depending on it. And we can cache a lot of this content. If, for example, your homepage is more or less static, then it's not going to depend on whether you have a session or not. So what we do is in our configuration, what we use in Clipping Book, we want to pass this cookie to the backend, but even still cache most pages, even if it's set. We must be careful, and this is something that Varnish is not going to handle for us. It's something that we have to take care in the design of the application, where this cookie really provides different response. One clear case is when there's logged-in users. When there's a user which is logged in, then the response is going to be very different than from a user which has never been logged in. But there are more hidden examples. For example, forms. Forms usually have a cross-site request forgery item, and this has to be different for every user. So if you have a form in a page, then you cannot cache it. There are techniques to do that, but mainly there's a problem. For example, if you use flashes, the session flashes, to provide messages to the users, you cannot cache that as well. So you have to take into account all these different cases and decide if you want to be able to cache a page or not. In our case, in Clipping Book, we use a very simple scheme, which is that we decided we didn't want to cache any page for logged-in users. It made the change on your particular case, but from all I've seen, all I've read, most of the time, it doesn't make sense to cache content for logged-in users. I mean, if your application is an application where most of the users are going to be logged in, then it's going to be difficult to make Varnish produce really good results for you. The best time when Varnish shines is when there's content where most of the content is seen by users which are not logged in. That's the case for Clipping Book, for example. In our case, there are 1,000 not logged in users for every logged in user. So we can decide not to cache anything for the logged in users because we know it's just 1 in 1,000. So that's no problem. That our backend can handle that without problem. And also, there are lots and lots of cookies, and many times more as we move functionality to the client. Nowadays, there are lots of things which are done in JavaScript, with Angular, whatever, and lots of the cookies that we produce are used by the client, not by the backend. So we send back and forth a lot of cookies which really don't produce any different content on the backend. They produce the same content, and then the JavaScript interprets it and shows something or whatever, and does. So these cookies can be safely ignored by Varnish. And finally, there are some cookies, this is a really interesting thing, which produce a different response, but it's the same for users. So for example, let's say you have a cookie which shows a newsletter box for users which haven't signed for the newsletter, and doesn't show this newsletter box for users who haven't signed for it. So there are just two versions of the web page. And a very intelligent thing to do is vary on them, because then you're telling Varnish that this page is mostly the same, it just has like these two variations which you can store. And one last thing about cookies is that usually we want to clear cookies for static content. It doesn't make sense to send cookies for files like images, JavaScript files, CSS files, because this really don't change between one client and the other. So it's useless to be changing cookies with the client all the time and deciding if we want to cache or not. With all this in mind, that was the configuration we wanted to handle. I want to show the VCL code that we came to. So for example, this is when we receive a request, the first thing we do is we save the cookie, that's the cookie header, in a special header where we just save it. Unless there's a cookie called logged in, which is a special cookie that we set up, then we delete all the cookies because we look at all the cookies, all the other cookies that we use in our application, we really weren't interested in the backend. And for any URL which is static, which has like these extensions for static content, we clear all the cookies as well. When it comes to time to calculate the hash, we recover the cookies because we are interested in using them to find the cache. Mainly why? Because as I said, we're going to vary on one of these cookies, which is this hide newsletter cookie. So I'm setting up this special header here, and I'm letting, I'll show you later on the next slide, I'm letting Varnish know that I want to vary on this special header that I set here. We're also recovering the cookies. We want to send them back to the backend because they may have some uses for them, like the session cookies. So if you pass directly the request to the backend, we also recover these cookies that we saved. And when we get the response, we are letting Varnish know, okay, you have to vary on this special header that I set up. So depending on if it's set or not, you have to keep 2 different versions. And also, if I get one of these static objects, I'm saying, I don't want any cookies that has been set on this, so just clear them. And the final thing that we have to do, this is something that you have to take care when you use vary. We use a special header we define here, but this is a header that only Varnish and our backend know about it. Any cache which is outside of here is not going to know about that. So if we tell them that we're varying on X newsletter, they're going to say, what? I don't know about that header, so I cannot vary on it. And it's probably going to serve wrong content, because since you didn't tell it to vary on the correct header, maybe it's going to serve content to a different version. So what we do is we convert this header to a header that outside cache can know. So we say, in fact, XNewsLetter is just a special case for the cookie header. So what we say, okay, we are pretending we are varying on the cookie header, and we send that back to any outside cache that might be out there. This is a bit complicated, but once you start working with Varnish, you get the hang of it. So you saw that we had this special logged-in cookie, which is just a cookie which is set if you're logged in, and is unset if you're not logged in. How did we do that? We defined a special listener, which is a kernel response listener, which is called just once the response has been generated. And what we do is we look at the context, the security context. We find out if you are logged in. If you are logged in and you don't have the cookie, we set it. And if you are not logged in and you have the cookie, we clear it. It's as simple as that. So in that way, the client is always getting this logged in or not logged in cookie. Oh, sorry. So next item, internationalization. This is another case where you want to return different content depending on a header. In this case, this is the accept language header. The problem with the accept language header is that it has many, many variations. You can have one browser saying it accepts UK English, another one saying I accept US English, another one Australian English, another one saying, I accept German if you have it, then Spanish, and if not Chinese, things like that. And you want to standardize that, because otherwise, if you say you're varying on that, you're going to end up with thousands of combinations in your cache, and you don't want to do that, because it's going to produce less cache hits, more memory occupied. So you want to normalize everything. So what you can do something like as simple as this. You take the accept language header and you normalize it to it's just English or Spanish or nothing else. And if it's something different, I just unset it and let the backend handle it whatever way they want. This is a bit simplistic. There are better ways to do that. You can look at this GitHub routine which is there, which is much more complex. It studies all your accept language. But the main result, final result is the same. You get a normalized accept language header, which you can use in your backend and to return the content, and which Varnish is going to vary on. One good thing to know is that Varnish, since version 3, will automatically take care of the accept encoding, which is the header which differentiates if the client accepts zip content or not. So you don't have to do anything about that. Varnish is going to take care about that, and it's intelligent enough to, for example, if you serve content which is not zipped, and the client says that they can accept zipped content, it's going to zip it itself and send it back in a zipped, and store in a zipped configuration. So it's rather intelligent about that, and it's really nice. Another case where we want to vary on a header, and we also want to do some normalization, is device detection. Maybe you serve a different content depending if it's a mobile browser, if it's a desktop browser, Android, iOS, whatever. Again, we want to normalize because user agents, there are thousands of them. Even within a single browser, you'll get Chrome 2.5, 2.7, 3.95. So you have to find a way to normalize because otherwise you're going to store thousands of variations of your content on your cache, and you don't want to do that. There's a really nice code, which you can also find on GitHub, which you can include in your Varnish configuration. It's as simple as that. You include it in your Varnish configuration, and you call device detect. And what this does, it sets a special header. Again, many times in Varnish you work with special headers. In this case, it's called XUA device header. And so this is set, and it's something really simple. There are I think it's like 5 different versions. It's Android, iOS, tablet or not, and desktop. So it normalizes everything. Again, you have to take care to let Varnish know that you are varying on this header so that it can store different content depending on it. And again, you want to transform this special header into a standard header when you send the response back, because outside cache don't understand this special header, so you have to transform it back into a regular user agent header. Okay, so we have this special XUA device header, and we have to do something about it. One easy way to do it is just when we go to the backend, what we do is we copy this special header to the user agent header. And so that's probably the easiest way to do it. You just convert it into a user agent, and then your code knows how to handle the user agent, and then they return a mobile or a desktop version, depending on whatever. The problem here is that we're losing information. So if you want to use your user agent header for anything other than device detection, if you want to keep logs or something like that, then you're losing this information. And in that case, you don't want to replace the user agent header, and you want to send it this special header directly. If, for example, for device configuration, we use this lib theme bundle, we can configure a special device detector, and then we can configure this device detector so that it uses this special header to decide if we are mobile or what. Okay, so to make Varnish work, we have to send back all the special caching headers that HTTP caching needs. So how do you do that with Symfony? One option is to set them directly in the response object, which is the standard way. But it's really nice to use the annotations. If you use Sensation Framework Extra Bundle, then you can use the cache annotation, and you can configure everything on your annotations on the actions of your controller. And even nicer than that is if you use a really nice bundle, which is called Friends of Symfony HTTP Cache Bundle, you can set this in your config file. You define a set of rules, which is the routes or the paths that need to be matched, and you define the cache control headers that need to be sent back. The best thing about this is that you keep all your caching information in a single place, so you don't have to go hunting with all the files to change. If you want to change, for example, the max age for some contents, then you don't have to go looking at all the files where it is. It's just everything in your config file. Next thing is cache invalidation. Cache invalidation is when there's something in the cache and you don't want it to be served anymore to the client. You want to refresh that content, and you want that to provide new content for the client. This is something which can be hard to do, but which Varnish makes easy and some bundles make easier. One of the first use case for this is when you have to update pages because you have deployed new code. You have deployed new code which shows something different in some way, and you want your pages to take the new look or the new functionality or whatever. If it's a minor and non-backward compatibility breaking change, the best thing to do is just wait for the cache aspiration headers to do their job. If you haven't set up your cache aspiration in 1 year in advance, you do something which is logical, and for example, you have content which expires every 10 minutes, then you just need to wait these 10 minutes and it will be available. There's no need to hurry or rush about that. But you may need to use some cache busting mechanism, like the asset version is used for assets. If you use cache validation, if you, for example, return content depending on the if an object has been modified or not, even if you add some new code, then this object is going to have not been modified. So it's going to say, okay, you know, I'm still valid, so it's going to still serve the old content. So you have to add some kind of cache busting, like a parameter or a version parameter or whatever that can be helped. If it's a major or a backward compatibility breaking change, in our case, what we do is just stop Varnish and reload it again. Because there are ways to just clear some content. I found them too complicated. In our case, we just go ahead, stop Varnish, and start again, which clears all the cache. Downtime is almost inexistent because Varnish is really fast starting. You can start in 1 second. So you get your site running right away. But the problem is that you lose all your cache content. If this is important for you, you can build a command which warms up this cache for you. Mainly what it does is just calling Varnish with all the URLs that you want to be on the cache. The second, terminamos? Okay. Let me finish with invalidation and that's it.
Just 1 minute.
Just a minute. The second very interesting use for cache invalidation is when you need to invalidate individual pages depending when the underlying data changes. For example, you have a book object, you change it, then you want to change all the pages which show this book, whether it's a list, book or list, or the book itself. The first thing to do is you need to configure Varnish to accept a special method which is called purge, so that it takes the content out of the cache. And the next thing you want to do is use a special bundle, which is this Friends of Symfony HTTP cache bundle. You configure a Varnish server so that it can communicate back to it. And then you have one service which can communicate back to Varnish and invalidate any path or any route that you want. And it's really, really nice because you can configure that with annotations. So for example, I'm seeing here, there's an action which is to edit book, and I'm saying, when I edit a book, I want to invalidate all the book list and any page which shows this book. And it's going to communicate back to Varnish and invalidate all this content. And finally, we can even do that in our config file. I'm defining here some routes, and I say, okay, when I call this route book edit or book delete, I want to invalidate the book list and the book show. One of the nicest things about this is that it's really intelligent. So, for example, there's a parameter with book edit, and you send an ID for the book. Then it's going to send the same ID for book show. So it's not only going to invalidate the same book that you have deleted or edited. And since I don't have any more time, I'll leave the S sites includes for S. So that's it. Any questions? Thank you very much.